Hello, this is NovaTopFlex, and in this video, I will be using the xterm terminal emulator, probably the default terminal emulator for simple window managers on Unix-based systems. The operating system, kernel is Linux, and the operating system is Ubuntu. So let me start while I'm still on the shell with the uname-a command. It will give me the stats, give me the system information before I get ready. So I'm now going to do, because I'm on Ubuntu, technically this is actually going to be Ubuntu 24.04 series, so on Ubuntu, that's what it is. Now, if you know anything about the Noble Numbat release of Ubuntu, Python 3.12 is a default version series. This is also the first long-term support release for which you no longer have a Python 2.7, although it's already unsupported anyway. So I'm going to go to Python 3.12, and in this case, I'm going to do import, and then OS, and then import again, and then sys. Now, there are very many possibilities. Now, I am going to open up the documentation browser separately, so follow along with what the documentation says. So I will go over bits and pieces of both the OS and sys modules. Note that for this demonstration, I may or may not cover, but probably will not cover all the possible commands, because these commands that can be performed on Python, I am on Linux. You may encounter a command that will only work on a Mac or Windows system. POSIX, NT, and Java are the three names that have been registered for the os.name. On Linux, it should say POSIX. If you are on Windows, the output should be NT, and Java systems, probably where you'll see Java. That is the most basic system. Now, os.error is just an alias for the built-in OS error exception. Now, for file names, command line arguments, and environment variables, so yes, this is UTF-8 mode. Now, this assumes that you are actually reading the documentation with me. But now I'm going to look at the the controlling terminal of the process. If you want to know the controlling terminal of the process, please do os.ctermid and then the parentheses. You need the parentheses. This is not a variable. This is a function. I'm sorry to say command. We technically call these functions. They're kind of treated as commands because this is an REPL situation. Read, evaluate, print, loop. So os.ctermid, this is going to be the controlling terminal. This is /dev/tty. So teletypewriter. And then os.environ, you can actually change different features. So, yes. If you call put env directly, it does not change os.environ. So if you really want to change what you're controlling on your terminal, like when I control my VNCs, I need os.environ in order to do so. So os.environ, you can actually use it, but yes. os.environ, again, it's going to be, I believe it's ordered tuples, tuples, I'm not sure exactly how to say it still, but I have associated it with the word two, so in my mind it's tuple, but it could be tuple. Now, this is actually, so each input is assigned to an output in os.environ. You can change the output for an input by calling with the os.environ. So, yes, if you need to change something, you change it on the os.environ. So, it can be a mess, and yes, this is just my example. But I have to warn you that depending on your system configuration, your information may be sensitive. At least in this demonstration, it's not. But it is a risk that you may be taking if you can perform this command on your system. I would not recommend that. for all users, especially. And then os.environb is just the bytes version of the same thing. So note that we actually have the B delimiter, I believe, for our strings. So now they're binary and not just regular strings. That is what the binary version of environ is supposed to be. Now, you need to have a file descriptor, FD. It may be difficult to understand the definition of file descriptor, but that'll be for another video. Now, os.fchdr, FD is the file descriptor. If you do os.chdr, fchdr, you need a file descriptor. You can do a regular path with os again. Sorry that I keep saying oh.chdr. The path can be anything. It could be os.curdir, curdir, or pardir. Now, curdir and pardir are just aliases for the current and parent directories, respectively. Dot and dot dot. And it doesn't matter if you're on the POSIX like I am, NT, or Java. It will always be that way. And get CWD means get current working directory. So, now, we also have so technically fsencode, or fsencode rather, encode a path-like file name to the file system encoding and error handler and return the bytes unchanged. That is with fsencode, and then you can do fsdecode. So if you ever need to do, and this will not be demonstrated, these two, you can encode and decode path-like file names to file system and from file system encoding error handlers. You can return the bytes unchanged with fsencode. You can return the stir unchanged with fsdecode. So these functions have direct reverse functions. fspath, and then you can return the file system representation of a given path. So for this OS file system representation, okay, so these are examples. Note that when you're actually performing the code, because I'm on the REPL, REPL, read, evaluate, print loop, it will have outputs for everything. To really output it on a real script, you normally will need to do the print command as well. To do that, or print function rather, I believe. It's not a command because commands are shell. Now, fspath, if stir or bytes is passed in, it's returned unchanged. Otherwise, it's called the fspath, and its value is returned as long as it's a stir or bytes object. In all other cases, type error is raised. And then path, like uppercase P, uppercase L, it is a class. Abstract method underscore underscore fspath underscore underscore, return the file system path representation of the object. And this should only return a stir or bytes object, and the preference should be for stir. Now, get env and set env, we do not recommend using those because environ is recommended. Now, note that depending on how you do it, you may have memory leaks on BSD and macOS systems. And the environ may depend also because of the differences between, now, get envb, that's going to be the binary version as well. Often with these commands, if it has a B suffix, it's binary. And then get exec path. So this is going to be typically the where is, or the which rather. I think it's usually a where is search. So I'm going to do my example. Okay, so these are the places that this computer would search for to locate executables. User local sbin, user local bin, user sbin, user bin, sbin, bin, user games, user local games, and snap bin. If you install a package using the snap package manager, it'll be in snap bin most likely. If not, usually system is going to be in bin and sbin. If you need sudo privileges, it's in sbin. If not, it's in bin. What if it is a user level one and not a system level one? then it's going to be in user bin, or if sudo is required, user sbin. Sometimes bin and sbin are actually aliases, and there is less of a distinction between system level and user level. But what is more obvious is user local bin and user local sbin. Again, usually sbin requires sudo, bin usually does not. User local is packages that you have manually installed. Like on this device, packages that have been manually installed include numerous types of shells and other applications. So the games, I do not have much in terms of games on this system, but executables could also be in that games directory. And it is similar to a shell. An env, when specified, should be an environment variable dictionary to look up the path in. Environ is used if env is none. Now, EGID of the current process is the effective group ID, so get EGID, set ID bit on the file be executed. Unix and not WASI, or what is that? WASI, honestly not sure what that is, though. Please tell me in the comments if you have any idea what WASI is, or if I'm even pronouncing it correctly. So that was get EGID, that's effective group ID. EUID is the effective user ID. And GID is a real group ID. Use get in front of all the IDs, so effective group ID, effective user ID, and real group ID. Let's start with the effective group ID. Okay, so the output is the effective group ID for this process. This is going to be the effective user ID, and then the real group ID. They're all the same, though that may not be true necessarily. And the real group ID is a stub on WASI. See WebAssembly platforms for more information if you're looking at the documentation. And then the get group list, so we return the list of group IDs that a user belongs to. Since this is just a simple demonstration, I'm not actually going to show the get group list. And if you have any more information, I would like to go over that in a future video also. This was added in Python 3.3 a very long time ago, sometime in the early 2010s, and it's not really been deprecated since, I don't think. But since it is a more complex one and there are more parameters, and also for privacy reasons, I typically will not showcase the get group list command. How about the get groups command? Supplemental group IDs associated with the current process will be on get groups. If you're a Mac user, on macOS, get groups behavior will differ somewhat from the other Unix platforms. If the Python interpreter was built with a deployment target of 10.5 Leopard or earlier, this is all the way back pre-2009, get groups returns the list of effective group IDs associated with the current user process, limited to a system-defined number of entries, typically 16, and modified by calls to set groups as suitably privileged. If built with a deployment target greater than Leopard 10.5, in more modern systems, 2009 and beyond, get groups returns the current group access list for the user associated with the effective user ID of the process. The group access list may change over the lifetime of the process. It is not affected by calls to set groups, and its length is not limited to 16 anymore. The deployment target value, macOS 10 deployment target, can be obtained with sysconfig.get_config_var. And then in parentheses, var is variable, like in many conventions for different programming languages. So that's going to be get groups, and then get login. It is more useful to use getPass.getUser instead of os.getLogin, since the latter checks the environment variable's log name or username to find out who the user is. And it falls back to pwd.getPWUID, and then parentheses, os.getUID, parentheses, and then final parentheses, and then the bracket 0. So it's going to be the first entry to get the login name of the current real user ID. But since I focus on the OS module, I will look at the get groups and get login. These are all the supplemental groups associated with this process. And this is actually multiple. This is sort of a list. First element of the list is 0, second element of the list is 1, and so on. But what if you are out of bounds? Well, normally that's what happens, so You can also do the negative one on the list, and that's going to go backwards. But you do have to stay in range when you look at lists, just so you know. Now, back to the get group situation, I'm now also going to do the get login, although recommend that we do not use that too much. And this is just the name of my YouTube channel, so I am NovaTopFlex, and while I do capitalize the T and the F on the YouTube channel, usually uppercase letters are not allowed in usernames on the default Linux, though you can change your username to have uppercase later. So just speaking about that, so that's what get login does. And then get PGID is going to return the process group ID of the process with process ID PID. If 0, the process group ID of the current process is returned. And you need to have the PID. You cannot leave it blank. Not on this one. And it's going to show us the process group ID of the process with the process ID. So this is the NovaTopFlex system. So this demonstration system had and still should have the number of the ID number at the bottom. Now, current process group is PGRP, and you do not need to add anything. And then PID is process ID. PID is a stub on WASI, and most of this is not available on WASI. But this is a Linux system, and still Unix-based, but something else entirely. So get PGRP and get PID. And then os.getppid. It's the parent process ID, and it's available on Windows since version 3.2 of Python. So unlike most of the OS commands listed so far, Windows is also supported, so yes. The difference is that on Windows it is still the same ID, which may be already reused by another process. Whereas on the other systems on Unix, it's the parent's process ID, and then the ID returned is the one of the init process when the parent process is exited. And then os.getPriority, and then who, I'm not going to demonstrate that, but it's program schedule a priority. Unix and not WASI. And then getPriority and setPriority functions, technically prio, underscore, and then process, PGRP, and user are available for the getPriority, setPriority. And these have existed on Unix systems since version 3.3. And then PRIO underscore Darwin underscore and then thread process BG and NONUI. These were added in the fairly recent version of Python 3.12. I know that we're on Python 3.13 at the time of this recording, and 3.14 is in the alpha stages of its series. So this is what the os.prio is for, and it actually is dependent. So Darwin is just for Mac OS, and the others are for all Unix-based systems. And then get resuid, it's the real, effective, and saved. It's a tuple or a tuple with get resuid and then get resgid, so resgid, GID. So RUID, EUID, SUID, or RGID, EGID, SGID. So yes. Okay, each value is the same as already mentioned before. And then get UID is also a Unix feature or a Unix function. We also have os.init groups that has a username, a GID, and then a slash. You call the system init groups to initialize a group access list with all of the groups of which the specified username is a member, plus the specified group ID. It is available on Unix, but not on Android, and like most of these commands, not on WASI either. This is actually another added in Python 3.2, so most of the OS modules functions have existed since Python 3.2. So on really old systems with 3.0 or 3.1, you may not be able to perform most of these functions. And then os.putenv, putenv, On some platforms like FreeBSD and macOS, setting env may cause memory leaks, so refer to the system documentation for the put env. It does not update os.env. So I already mentioned the BSD and Mac warning earlier. Now set EGID and set EUID will set the current process's effective group ID and user ID. Normally these are commands I wouldn't use on the demonstrations anyway though. And then set GID would be for group ID. And then set groups is going to set the list of supplemental group IDs associated with the current process to the groups. On macOS, 16 is your typical maximum number of effective group IDs. Get groups for cases where it may not return the same group list set by calling set groups. And then set NS will reassociate the current thread with a Linux namespace. You have a file descriptor and you have an NS type equals 0 situation, like os.o_rd only. That's read only. And we have different examples. Linux, you must have a Linux kernel that is greater than or equal to version 3.0 with, or 3.0 rather, with glibc it must be greater than or equal to 2.14. And this was added in version 3.12, by the way, the setNS. And it is related to the unshare function. Also, os.setPGRP, again, this is going to be the PGRP, this group, call the system call of setPGRP or the setPGRP 00, depending on which version is implemented, if any. And for the semantics, the Unix manual, you should see the Unix manual rather for the semantics and the details. And then PGID is for setPGID. It calls the system call for setPGID to set the process group ID or the process with ID PID with process group with ID PGRP, or to it rather. See the Unix manual for more semantics beyond the documentation. This assumes you're following along with the Python documentation. Set priority, you can set the program scheduling priority, the value which is one of the prio process, prio PGRP, prio user, and who is interpreted relative to which. A process identifier for prio process, group identifier for prio PGRP, and user ID for prio user. A 0 value for who denotes respectively the calling process group of the calling process, or real user ID of the calling process. Priority can be in the range of -20 up to 19, but 0 is the default priority, and lower priorities cause more favorable scheduling. Available on Unix and not on WASI, and introduced in Python version 3.3. The real and effective group IDs can be set together with the set REGID, and you can also add the saved one to it with the whole triple, the entire one, RESGID. You can also do RESUID. This will change it to just the user IDs. You can also do REUID. That'll just be real and effective and not saved user IDs. These are not available on Android and not available on WASI. These are available on Unix. And the RESGID and RESUID are new to Python 3.2 a long time ago. os.getSID is going to call the system call getSID. And see again the Unix manual for the semantics if you want to learn more. Available on Unix but not on WASI. You can do getSID and you can do setSID to set the system ID, or really it's the saved ID rather. UID is the user ID. SetUID for Unix but not for WASI or Android. And then str error, that's stir error. Return the error message corresponding to the error code in code, whatever code is. On platforms where stir error returns null when given an unknown error number, value error is raised. os.support_bytes_environ. It is true if the native OS type of the environment is bytes, like on Windows it would be false. And this is actually Python 3.2 edition, so I'm going to test this command, or rather function. Or rather, actually, it's variable. Sorry. That was misspelled. True! This is Ubuntu, which supports bytes environ. You can do os.umask. It is a stub on WASI, but it is available on Unix otherwise in general. Set the current numeric umask and return the previous one with os.umask and then mask and slash. os.uname. So uname is basically just the same as uname. It's a 5-tuple or 5-tuple containing sysname, node name, release, version, and machine in that order. For backwards compatibility, and you can also divide it up as well. So uname may not be identical to the uname command on, for instance, the shell. So I'm now going to do this, and I'm going to do the example proving if it is actually the... So this is going to be a POSIX.uname result. So really... So this is going to be value, the first value is 0, the second value, so 0 is sysname, 1 is node name, 2 is release, 3 is version, and 4 is machine. So it is actually a 5-tuple containing these items. Some systems will truncate the node name to 8 characters or leading component, so you really should use the socket module, which will not be covered in this video. Please check in with Nova Top Flex regularly for more information. The socket module may be coming soon. You can even do socket.getHost by adder, socket.getHostName. You could do the getHostName inside of a getHost by address command if you want to do it, or function rather. Function within function is totally acceptable in cases where that is allowed in Python. On macOS, iOS, and Android, this will return the kernel name and version, such as Darwin on macOS and iOS, and Linux on Android. The kernel name and version will be represented. Platform.uname can be used to get the user-facing operating system name and version on iOS and Android. And this is available on Unix-based systems. Prior to version 3.3, the return type was a tuple. Now it is a tuple-like object. An onsetEnv is onset or delete the environment variable named key. Such changes to the environment affect subprocesses started with os.system, popen, or fork, and execv, execv. Deletion of items in os.environ is automatically translated into a corresponding call to onsetEnv. However, calls to onsetEnv don't update os.environ, so it is actually preferable to delete items of os.environ. This will raise an auditing event for os.onsetEnv with argument key. And this, by the way, is changed with Python 3.9. So before, the function was not necessarily available and not on Windows either. But now it is always available, including on Windows. And then os.onshare is going to disassociate parts of the process execution context and move them into a newly created namespace. See the man page for more details. Unshare 2. Manual. The flags argument is a bit mask, combining 0 or more of the clone asterisk constants that specifies which parts of the execution context should be unshared from their existing associations and moved to a new namespace. If the flags argument is 0, no changes are made to the client process's execution context. This is for Linux greater than or equal to 2.6.16, and this was added in Python version 3.12. You can also see the setNS function for more information. And this flags to the unshare function if the implementation supports them. In the Linux manual, the exact effect and availability should also be there. Now, file object creation, you have clone files, fs, new cgroup, new IPC, new net, new ns, new PID, new time, new user, new UTS, sighand, sysvsem, thread, and VM. These are all after the clone underscore, by the way. And these functions create new file objects. You can also see open for opening file descriptors. os.fdopen returns an open file object connected to the file descriptor fd required, and then you have the args and the kw args. And then the only difference with open versus fdopen is that the first argument of the fdopen must always be an integer. File descriptor operations. These operate on I/O streams referenced using file descriptors. os.close will close the file descriptor. Close range will close all file descriptors from the low one inclusive to the high one exclusive, ignoring errors. Equivalent to, but much faster than, trying a for loop to try with the OS error exception and pass for a range from fd low to fd high. The copy file range is copy a count number bytes from file descriptor src, starting from offset src to file descriptor dst, or starting from offset dst. If offset src is none, then the source is read from the current position, respectively, for offset descriptor. Older than 5.3 Linux kernel, this will be the source and descriptor, and they must reside in the same file system. Otherwise, an OS error is raised in these older Linux kernels with error no set to error-no.xdev, exdev. And this copy is done without the additional cost of transferring data from kernel to user space and then back into the kernel. Additionally, some file systems could implement extra optimization, such as use of ref links, such as 2 or more inodes that share pointers to the same copy on write disk blocks, with supported file systems including BTRFS and XFS, and server-side copy in the case of NFS. The function copies bytes between 2 file descriptors. Text options, such as the encoding of the line ending, are ignored. The return value is the amount of bytes copied. This could be less than the amount requested even. On Linux, os.copy file range should not be used for copying a range of a pseudo file from a special file system like procfs and sysfs. It will always copy no bytes and return 0 as if the file was empty because of a known Linux kernel issue. Linux greater than or equal to 4.5 with glibc greater than or equal to 2.27. This OS function was added in version 3.8. Device encoding rather. The encoding associated with the file descriptor if connected to a terminal. It changed in Python 3.10. Since 3.10, the function now implements the UTF-8 mode on Unix. And if the Python UTF-8 mode is enabled, return UTF-8 rather than the actual device encoding. So and then os.dup is a duplicate of a file descriptor fd, and the new file descriptor is non-inheritable. But on Windows, when duplicating a standard stream, std in, std out, std error, std means standard, standard input, standard output, standard error, the new file descriptor is inheritable. And this is not available on WASI, but is available everywhere else. The new file descriptor became non-inheritable in version 3.4. In the DUP2, duplicate FD to FD2, closing the latter first if necessary. Return FD2. The new file descriptor is inheritable by default, or if inheritable is false, non-inheritable. The inheritable parameter is optional, and has been optional since 3.4. And since 3.7, FD2 would be returned on success. Previously, none was always the output. Now, fchmod is going to be to change the mode of the file given by FD to the numeric mode. See the docs for chmod for possible values of mode. As of Python 3.3, this is equivalent to os.chmod fd mode, file descriptor, and mode. And this raises an auditing event os.chmod with arguments path, mode, and dir fd. This is available on Unix and Windows, but is limited on WASI, as with most of the WebAssembly platforms. os.fchown or chown rather, fd uid gid. Change the owner and group ID of the file given by the file descriptor to the numeric uid and gid. To leave one of the IDs unchanged, set it to -1. chown. As of 3.3, this is equivalent to chown, fd uid gid. This raises an auditing event, os.chown with arguments path, uid, gid, and dir fd. This is available on Unix only, or Unix-based systems only, but it is limited on WASI. It is not a non-existent one. See WebAssembly platforms, as always with WASI, for more information. To force the write of a file with the file descriptor fd to disk, you do os.fdatasync. This will not force the update of metadata, and this function is not available on macOS, but is available everywhere else on Unix. fpathconf. Return system configuration information relevant to an open file. The name specifies the configuration value to retrieve, which may be a string, which is the name of a defined system value, specified in a number of standards, including POSIX 1, Unix 95, Unix 98, and others. Some platforms define additional names as well. The names known to the host operating system are in the pathconf_names dictionary. For configuration variables that are not included, passing an integer for name may also be acceptable. If name is a string and is not known, then Python raises a value error. If not supported by the host system, even if in pathconf names, an OS error is raised with error_no.einval for the error number. This has become equivalent to pathconf fd name as of Python 3.3 and is available on all Unix systems. fstat returns the status of the file descriptor fd, returning a stat result object, and equivalent to os.statfd since Python 3.3, related to the stat function. os.fstatvfs is like statvfs and is equivalent to statvfs as of Python 3.3. fsync force the write of a file with file descriptor fd to disk. On Unix, this will call the native function. On Windows, it's the ms_commit function. If a buffered file object in Python is being started with first, such as with f, it's f.flush and then do os.fsync f.fileno and then parentheses to ensure that all internal buffers associated with f are written to disk. Truncate the file corresponding to file descriptor fd so it is at most length bytes in size, so it's fd length and slash. Since version 3.5, Windows had been supported. Previously it was Unix only. And an auditing event is raised with os.truncate with arguments fd and length. And then getBlocking will get the blocking mode of a file descriptor. If the oNonBlock flag is set, it is false. If cleared, then it is true. SetBlocking and socket.socket.setBlocking are related. This is available on Unix and Windows, but is limited on WASI. And on Windows, this is limited to pipes. This function was added in version 3.5, but pipes on Windows have not been supported until version 3.12, so if you're on an older version of Python, then Windows pipes may not be supported yet. And then os.grantpt grants access to the slave pseudo-terminal device associated with the master pseudo-terminal device to which the file descriptor fd refers. And even upon failure, this file descriptor is not close, and this calls the C standard library function of grantpt. This is available on Unix, but not on WASI, and is not available on my demonstration with Python 3.12. To use the grantpt function, you must use version 3.13 or later. os.isAtty, you need a file descriptor and then the slash in example. Return true if the file descriptor is open and connected to a teletypewriter-like device. Elsewhere, it is false. os.lockf is to apply, test, or remove a POSIX lock on an open file descriptor. fd is an open file descriptor. cmd specifies a command to use. It can be one of the flock, ftlock, fulock, or ftest. And then len specifies a section of the file that should be locked. This will raise an auditing event, lockf, with the arguments fd, cmd, and len length. This is available on Unix only, and this is a command from version 3.3 of Python onwards. flock, ftlock, fulock, and ftest are flags that specify the action the flock is supposed to take. Available in Unix since version 3.3. Login TTY is new to Python 3.11 and is available on Unix but not WASI. This is to prepare the TTY of which file descriptor or which FD is a file descriptor for a new login session. This will make the calling process the session leader and make the teletypewriter the controlling one with the standard input, standard output, and the standard error of the calling process. And the file descriptor will be closed. os.lseek will set the current position of the file descriptor fd to position pos modified by whence and return the new position in bytes relative to the start of file. So fd position whence slash. Valid values for whence are seek set or 0 to set the position relative to the beginning, seek cur or 1 setting to the current position, or seek end or 2 for the end of the file. You can also do seek whole to set to the next data location relative to position, or seek data to the next data whole relative to the position. Whole for location and data for whole. And seek whole and seek data were added to this command in version 3.3 of Python. Seek set, seek cur, and seek end are 0, 1, and 2 respectively. And seek whole and seek data again have existed from from version 3.3, but Linux kernels from 3.1 onwards are supported. So Linux can be 3.1 or above with Python 3.3 or above. macOS and other Unix is also supported with these parameters. os.open can open the file path and set various flags according to flags. This is going to be an octal. It can be 00777, but that's with all read, write, execute. But it is an example mode, and then according to mode, possibly. When computing mode, the current umask value is first masked out. You return the file descriptor for the newly opened file, and it is going to be a non-inheritable one. For description of the flag and mode values, the runtime documentation for C should be consulted. Flag constants like O, RD only, and OWR only, these are read only and write only, and these are defined in the operating system OS module mentioned. In particular, on Windows, adding O binary is necessary to open files in a binary mode. This function can also support paths relative to directory descriptors with a dir-fd parameter, and this will raise an auditing event open with arguments path, mode, and flags. Since version 3.4, the new file descriptors become non-inheritable. Since 3.3, the dir-fd parameter had been added. Since 3.5, if the system call is interrupted and the signal handler does not raise an exception, the function now retries the system call instead of raising an interrupted error exception. See the PEP 475 for the rationale. And since 3.6, path-like objects are now accepted on the os.open. And this will raise an auditing event, open, with the arguments path, mode, and flags. And then the constants that are available on Unix and Windows. The os.o underscore, and then rd only is read only, wr only is write only, rdwr is read write, append, and then creat, exel, and so that's create, exel, and trunc, trunc. These constants are available on Unix and Windows. And then the following constants are only available on Unix and not on Windows. Desync, rsync, sync, ndelay, nonblock, noctty, and clo-exec. And the oclo-exec constant had existed since version 3.3. Additional Windows-only constants are binary, no inherent, short-lived, temporary, random, sequential, and text. And for macOS, there's EVT only, fsync, symlink, and no follow any. Extensions of these constants that are not available if not defined by the C libraries that are relevant are async, direct, directory, no follow, no atime, path, tmp file, temp file, either way, same thing, tmp file, tmpfile, and then shlock and exlock. Since version 3.4, OPath was added on systems that support it, and temp file was added only for Linux kernels 3.11 and newer. For the macOS version, OEVT only, OFsync, OSymlink, and ONoFollow any constants were new to Python 3.10. os.openpty is going to add a new pseudo-terminal pair, returning a pair of file descriptors, master and slave, for the PTY and the TTY, respectively. These file descriptors will be non-inheritable. For a slightly more portable approach, the PTY module is recommended. Please do not use the OS module for more portability. os.pipe is used to create pipes, and for both OpenPTY and pipe, file descriptors have been made non-inheritable from Python 3.4 onwards. Pipe 2, new to Python 3.3, this creates a pipe with a flag set automatically, and they can be constructed by O-ring together one or more of these values. O non-block and O clo-exec. Return a pair of file descriptors, R and W, usable for reading and writing respectively. This is available on Unix, though not on WASI, and was added in version 3.3. os.postfxallocate ensures that enough disk space is allocated for the file specified by FD file descriptors starting from offset and continuing for len bytes, length bytes. Added with 3.3. And then os.postfxadvise announces an intention to access data in a specific pattern, thus allowing the kernel to make optimizations. The advice applies to the region of the file specified by FD starting at an offset and continuing for len length bytes. Advice is one of postfxfadv normal, postfxfadv sequential, postfxfadv random, postfxfadv no reuse, postfxfadv will need, or postfxfadv don't need. This is available in Unix systems only and is new to Python 3.3. Normal, sequential, random, no reuse, will need, and don't need can be used in advice to specify the access pattern that is likely to be used. And then os.pread is going to read at most n bytes from file descriptor FD at a position of offset, leaving the file offset unchanged, and it returns a byte string containing the bytes read. If the end of the file returned to has been reached, an empty bytes object is returned. This is available on Unix only. POSIX_OpenPT with O flag and slash. This opens and returns the file descriptor for a master pseudo terminal device. This will call the C standard library function of POSIX OpenPT. The O-flag argument is used to set file status flags and file access modes as specified in the manual page of POSIX OpenPT of your system. The return file descriptor is non-inheritable. If the value o-clo-exec is available on the system, it is added to O-flag. And this is available on Unix, but not WASI, and is new to Python 3.13. And then preadv is for file descriptor FD at a position of offset and immutable bytes-like object buffers, leaving the file object unchanged. Transfer data into each buffer until it is full, and then move on to the next buffer of the sequence to hold the rest of the data. The flags argument contains a bitwise OR of 0 or more of the following flags. This is RWF high pri and then RWF no wait. And this will return the total number of bytes actually read, which can be less than the total capacity of all the objects. FD, buffers, offset flags, and then slash. The operating system may set a limit, syscomp value, SCIOV max, on the number of buffers that can be used. And this combines the functionality of os.readv and os.pread, and is available on Linux systems greater than or equal to kernel 2.6.30, FreeBSD greater than or equal to 6.0, OpenBSD 2.7 and above, and AIX 7.1 and above. AIX, by the way, if you didn't catch that. And using flags requires a Linux kernel to exceed or at least match 4.6. This is new to Python 3.7 and the 3.7 series. Now, high pri and no wait are also new to 3.7. For no wait, you must use kernel 4.14 or above. For high pri, 4.6 or above. And then os.pts name will return the name of the slave pseudo-terminal device associated with the master to which the file descriptor FD refers, but it is not closed upon failure. And this calls a reentrant C standard library function pts name _r if available. Otherwise, the C standard library function pts name, not guaranteed to be thread safe, is called. New to 3.13. Pewrite writes a bright string and stir to file director FD at position of offset, leaving the file offset unchanged. And this will return the number of bytes actually written, FD stir offset slash. New to Python 3.3. Pewrite v will write the buffer's contents to file descriptor FD at an offset. So this is FD buffers offset flags equals 0 or whatever, and then slash. The offset is called offset, and it leaves the file offset unchanged. Buffers must be a sequence of byte-like objects, or bytes-like objects. Buffers are processed in array order. Entire contents of the first buffer are written before proceeding to the second, and so on. The flags argument contains a bitwise OR of 0 or more of the following flags: RWF desync, RWF sync, and RWF append. And this returns the total number of bytes that is actually written. The operating system may set a limit, syscomp value again, SCIOV max, the number of buffers that can be used. Same requirements as before, 4.6, availability, Linux, FreeBSD, OpenBSD, AIX, added in 3.7, and RWF desync, sync, and append. They all require Linux greater than or equal to 4.7 for desync, sync, and new to 3.7. And for append, it's new to 3.10, and you need Linux greater than or equal to 4.16. So this is going to be the OS. So RWF is the same as O for desync, sync, and append. And then os.read. Since Python 3.5, if the system call is interrupted and the signal handler does not raise an exception, the function now retries the system call instead of raising an interrupted error exception. And this is intended for low-level I/O, and it must be applied to a file descriptor as returned to OS open or pipe. To read a file object returned by a built-in function opener by popen or fdopen or sys.stdn standard input, use its read or read line methods. os.sendFile. This is going to copy a count number of bytes from file descriptor in_fd to file descriptor out_fd starting at offset. This will return the number of bytes sent. When the end of file is reached, return 0. The first function notation is supported by all platforms that define the sendFile command, or sendFile function. In Linux, if offset is given as none, the bytes are read for the current position of NFD and the position of NFD is updated. The second case may be used on macOS and FreeBSD, where headers and trailers are arbitrary sequences of buffers written before and after the data from NFD is written. It returns the same as the first case. On macOS and FreeBSD, a value of 0 for count specifies a send until the end of NFD is reached. All platforms support sockets as an outFD file descriptor, and some platforms allow other types, such as regular files or pipes, as well. Cross-platform applications should not use headers, trailers, or flags arguments. This is available on Unix but not on WASI. Added in version 3.3 with out and in renamed to outfd and infd in 3.9. For a higher level wrapper send file, see socket.socket.send file instead. SF, NODISKIO, MND wait, and sync are parameters of the send file function if supported by the implementation. Available on Unix, though not on WASI, and new since Python 3.3. Or new to it, rather. An SF no cache is new to Python 3.11, and is another parameter if the implementation supports it. The data will not be cached in the virtual memory and will be freed afterwards. Set blocking, new to 3.5, with pipes on Windows added on 3.12. We'll set the blocking mode of the specified file descriptor. See the O non-block flag if blocking is false. Clear the flag otherwise. Limited on WASI, you can see the WebAssembly platforms for more information. Spliced will transfer account number bytes from source, starting from offset source to file descriptor DST. This is descriptor. At least one of the file descriptors must refer to a pipe. If the offset source is none, then source is read from the current position, respectively, for offset descriptor. The offset associated that refers to a pipe must be none. The files pointed to by source and descriptor must reside in the same file system, otherwise an operating system error is raised with error node set to error_node.xdev. This copy is done without the additional cost of transferring data from the kernel to user space and then back into the kernel. Additionally, some file systems could also, implement extra optimizations. The copy is done as if both files were open binary. Upon successful completion, return the number of bytes spliced to or from the pipe. A return value of 0 means end of input. If a pipe is being referred to for SRC, this means that there was no data to transfer and it would not make sense to block because there are no writers connected to the right end of the pipe. For os.splice, this is new to Python 3.10 and requires Linux greater than or equal to 2.6.17 with glibc greater than or equal to 2.5. Splice, F, move, non-block, and more are added in Python 3.10 as well. Since 3.3, there is os.readv, to read from a file descriptor fd into a number of mutable bytes-like objects buffers. Transfer data into each buffer until full, and then move on to the next buffer in the sequence to hold the rest of the data. Return the actual total number of bytes read, which can be less than the total capacity of all the objects. Same thing, SCIOV max limit, and added in version 3.3. os.tc get pgrp and tc set pgrp return the process group and then set it, respectively, both associated with the terminal given by fd. An open file descriptor as returned by os.open, and for the set, it's to pg. This is for Unix and not for WASI, though. TTY name will return a string that specifies the terminal device associated with the file descriptor fd. If not associated with the terminal device, an exception is raised, and this is available on Unix systems. Unlock PT will unlock the slave pseudo-terminal device associated with the master pseudo-terminal device to which the file descriptor fd refers. The file descriptor is not closed upon failure. This calls a C standard library function of unlock PT. This is new to Python 3.13 and is available on Unix, though not WASI. os.write will write the byte string and stir to file descriptor fd, and it will return the number of bytes actually written. This is intended again for low-level I/O and must be applied to a file descriptor as returned by os.open or pipe. To write a file object returned by the built-in function open or by popen or fdopen or even sys.stdout or sys.stderr, use its write method. Change in version 3.5 was that if the system call is interrupted and the signal handler does not raise an exception, the function will retry the system call instead of raising an interrupted error exception. So the system call got retried since 3.5. Prior, it was just the interrupted error. And then os.writev writes the contents of buffers, the file descriptor fd. Buffers must be a sequence of bytes-like objects. Buffers are processed in array order. Entire contents of the first buffer is written before proceeding to the second, and so on. This will return the total number of bytes actually written. Same sysconf value limit, and again, Python 3.3. Querying the size of a terminal. Now, this is actually where I'll stop the video for today. Hopefully, check back on another day's video for more information. Goodbye. For now, anyway.